So, no at the end. Our home plate for today, it's only 6 problems, and they all are, if you notice, absolute value equations involving absolute value equations. So make sure if you didn't have time to finish copying here in class, go to the YouTube video, it should be uploaded. And we're already almost done, halfway done with our Algebra 1 standards. So our objective for today, I can solve and graph one variable equations involving absolute values. I can solve and graph one variable equations involving absolute values. So you remember what concept we're still on so far? Yeah, one variable equations. And today we're still solving and graphing, but we're going to focus on absolute value. Okay? Here we go. I'm going to leave it up here on my screen, but I'll move your screen. Let's see. On your screen, you should have a Frayer model, and it reads one variable equations. So, let me send you a blank one. I want you to fill that out as writing on it. Don't type it in or don't take the picture. Just write it on the screen. Quick definition for one variable equations, one example, one unexample, and a hashtag. Give you some time. Ready, go. Does it look like that? Something like that? Pretty good, right? Yeah? All right, so what steps did we use last week? We said simplify, isolate, plot, and check. Simplify, isolate, plot, and check. What are the steps? Simplify. Okay, so for today, since we are dealing with something very special, which is absolute values, we're not going to use those steps. We're going to use a specific step. So here we go. 3 steps. Look at these. Look at the ones in blue. It says isolate the absolute value using inverse operations. Write the 2 equations without absolute value symbols and solve each equation. Copy those 3 steps, please. No, just numbers 1, 2, and 3 in blue. Don't copy the ones in black. Copy those. All right, writing pencils down, look up to the screen. I'm going to do a quick intro for absolute values. Once again, we want to make sure we understand the concept of just the basic absolute value before we move on to functions of absolute value, which is what we're going to see in a little bit. Not today, but pretty soon. So, what are absolute values, or what is the absolute value? Look up to the screen. The absolute value is the distance of a number away from 0. 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 The absolute value is... That is correct. The distance of a number away from 0. So, one symbol that we use for absolute values are these 2 parallel lines. You've seen it before. Now, let me tell you why we use those. Look over here with me. Since we're looking at the distance from 0 to a number, notice what I do here. Don't they look like 2 parallel lines? Yeah. And what is it? The distance of a number away from 0. That's why we use those parallel lines. Now, one way of presenting it is using the number line. Look up. Here's the number line. And question is, what is the distance of negative 23 away from 0? Well, 1, 2, 3, 4, 5, 6, 7, 8. How many steps? I know, right? How many steps is it away from 0? 23. Do we say negative 23? No. Therefore, what can we establish since right now? The absolute values are all positive. So you know what I just said? Yeah, like what if I said, okay, Nayeli, can you go outside to the gym and bring me my ID card and count the steps that you take from here to there and back? And then she's going to, okay, and then she goes 589. And then I'll say on her way back, negative 500. No, it's the same distance, 589, 589. Therefore, the distances are counted as in positive numbers. That's why, who remembers in elementary and middle school when your teachers told you all the absolute values become what? Positive. Why? Because they involve distances. All right. Now, another way of saying what is the distance of negative 23 away from 0 is this. What is the absolute value of negative 23? This is the same as this. Can you identify that? Okay, so now check this out. Now with symbols, how does this look? It looks like this. Absolute value of negative 23. And by now, what does this mean? What is the distance of 23 from 0? So what is the distance? 23. All right. So we got this, yes? All right, so check this out. Let's say I gave you this statement. Let me show you how to translate really quick. I'm going to write an equation. Focus, please. First, I'm going to start with the word is. When we have word problems, tell your neighbor what symbol does the word is represent. That is correct. Equal. There it is. I got that. Equal to what? What does this say? 23. Okay. Now, what does this say? Away from 0. What do we know this is? The absolute value. Away from 0, the absolute value. Now check this out. This is where we want to go here. What number? Do we know the number yet? No, so what can I write in here? X. So now I just translated an equation into an absolute value. Now, let me show you with the process I gave you, the 3 steps, how to solve these. Ready? Here it goes. Step 1, isolate the absolute value. Is the absolute value by itself on one side of the equation? Yes, here it is. Okay. Step 2, write 2 equations without any absolute value sign. Now check this out. Why 2 equations, Mr. Q? Because we have negative 23 and we have what? Positive 23. Therefore, we write whatever's inside, x equal to that, and then x equal to that. Do we have 2 equations now? Can we solve anymore? No, at that point we're done, and here's my number line. How does it look on the graph? Like this, and like this. Copy that, please. This is example Q. All right, with that said, here we go. So look at this one. Now, this is just like the one we just did. Don't copy this, but check this out. Oh, my bad. Yeah, here we go. There it goes. Here we go. Is the absolute value by itself? Yes. Okay, so at this point, what is the next step? Write 2 equations. So from there, I write what? X equals what? Negative 12, and x equals, and then we just plot, and we're done, yeah? 1 negative, 1 positive. All right, continue. Okay, write your utensils down. Look at this one. Here it goes. Going to get in a little bit interesting. Line down the equal sign. Here it goes. Is the absolute value by itself on one side? No. What's next to it? Negative 3 or minus 3. So what is the inverse? Plus 3 plus 3. We got absolute value of x equals 26. Do you know what to do from there? Okay, copy that and finish it off. This is example 1B. 1B. All right, here we go. Let's see if you got this. From here, we have 2 equations, 1 negative and 1 positive. So x equals negative 26 and x equals 26. And you know how to plot, yes? All right, let me move on. Okay, writing utensils down. Please pay attention to this part. This is where I lose about a third of you. So make sure we understand what we're looking at. Here we go. Writing utensils down, look up. Line down the equal sign. Do not answer. Keep this in your head. Here goes the question. Is the absolute value by itself? Keep it to yourself. Correct answer is yes. Some of you were thinking no because you saw more stuff here. But look where it's at. Where is it at? It's inside the absolute value. My question is the absolute value by itself, meaning this? Here's the absolute value. If it's not by itself, then it probably has a number in front of it, behind it, or below it. Look at this. Does it have a number in front of it here on this side? No. Behind it? No. Below it? No. Therefore, it's by itself. It's already isolated. Are we clear on that? All right. So now we go to step 2. What is step 2? Write 2 equations. Why 2 equations? Because we need one negative and one positive. One negative and one positive. But which one will be our negative, everyone? 8. Because that's the number by itself, the constant by itself. So negative 8 equals 2, and then we write whatever's inside, x minus 2.5. How about this side? It's a positive what? 8 equals what's inside? X minus 2.5. What is the last step? Solve each equation. Can we solve each equation? All right, copy that and let's finish it off together. On top of the number inside? Over here? Right here? We'll get to those eventually. So to solve these, once again, line down the equal sign on both, and we use the inverse operations, yes? Plus 2.5 plus 2.5. We're left with negative 5.5 equals x, and plus 2.5 plus 2.5, so therefore 10.5 equals x, and we know how to plot those solutions, yes? Okay? How are we feeling, yes? Okay? Alright, so up to right there, I think we're fine. The only thing we needed to clarify is what does it mean by absolute value being isolated, right? Alright, now we're going to get into this next one that's a little funky, but I just want to show you what it looks like, so like that, you can see a different way of approaching also absolute value. So check this one out. Look up to the screen. We have absolute value of y minus 3 plus 10 equals 8. Writing utensils down, look up to the screen. Check this out. Line down the equal sign. Is the absolute value by itself? No. What's next to it? Plus 10, so how do we get rid of that? Minus 10 minus 10. We're left with absolute value, y minus 3, and all that equals to negative 2. Now before I continue from there, let me go to the previous ones. Let me make a point to let's make sure you got it. Notice the absolute value is by itself here, yes? And it's equal to a positive number. Do you guys notice that? How many solutions did we get? 2. Here, absolute value is by itself. We ended up with a positive number here. How many solutions at the end? 2. Here, we have absolute value by itself. What number do we have here? A positive. How many solutions? 2. So look where we end up here. What do you guys notice? It's a negative. So question, is this true? Talk it over to your neighbor. Is this true, yes or no? And why yes, why not? Talk it over to your neighbor. Alright. Elaborate for us. Jacob. Yes or no? Why not? An absolute value cannot be a negative because it counts what? Distances, right? And distances are what? Positive. Therefore, what do we do here, Mr. Q? Well, if this is not true, that means it's false. That means it's no solution. Copy that, please. If you want to make a little note for yourself, put an asterisk, heart, aww, and then write yourself a little note next to it. Before here? Yeah, we'll get to them. All right, here we go. So far so good, yes? All right, look at this one. Okay, look up, writing utensils down, line down the equal sign. What do I do here, everyone? Add 8, add 8. We're left with 0. You're like, wait a minute. We did all the beginning were all positives. We got 2 answers. Check this one out. Positive numbers, 2 answers. Negative number, no answers. 0. One answer. That is correct. Why? Because there cannot be a negative 0 or a... Because from here, guys, remember that we do two equations? Because the absolute value is by itself. But since we have a 0, this is the only time we write 0 equals to whatever's inside, and we solve. We only have one solution. Copy this one, please, and finish. Minus 2 minus 2. We're left with negative 2 equals x. And there you go. Copy that. So what can we conclude with absolute values? We've been working with absolute values, and there's only three options. What are the three options? That we have two solutions if the absolute value is equal to a what? Positive number. One solution if the absolute value is equal to a what? And no solutions when the absolute value is equal to a negative number. So look for those on the home plate. Now in the home plate that I gave you, you're going to get some of these. Watch. I gave you stuff like this. 2 absolute value x plus 1 absolute value minus 3 equals to, give me a number? 3. Alright, so check this out. Look at it. What operations do we have outside the absolute value? Multiplication. Alright, here we go. Look up, please. What operations do we have outside the absolute value? Multiplication and subtraction. If this was a regular equation, which sign do we start with? No, because these are not parentheses. That's what I want to make sure. If this was an equation, then I would start with what? Subtraction. That means I add 3. I add 3. That leaves us with 2 times the absolute value x plus 1 equal to 6. So what would be my last step? Divide by 2, divide by 2, x plus 1 absolute value equals to 3, and you know what to do from there. Yes. Example super cute. Copy that one, at least we can have as a sample. Wow, he took a minute from me. That's all right. We got one more bump to go. Copy that, please. All right, and lastly, look up to the screen. I'm going to give you a word problem on the home plate. Look at this one. Sydney Harbor Bridge is 134 meters tall, and the height of the bridge can rise or fall by 180 millimeters because of the change of temperature. So how many millimeters does it go up or down? 180. So that's the number that changes. Is that correct? So check this out. To write an equation, this is our standard form of an absolute value equation. Absolute value x minus blank equal to blank. So we have two numbers here. We know that in an equation, absolute value equation, this becomes positive and negative. Is that correct? So which of these two goes there? Let's see. This is 134 feet tall. That never changes. But the number that it goes up and down is what? That means it goes up. That means it's a positive and negative down. So that goes right here. Does that make sense? Yeah. And then the 134 goes over here. However, what else do you notice different? Meters and millimeters. Make sure the conversion is the same for both. Okay? So you're saying, how do we do that? We'll convert this into meters times 1,000. Okay? All right? Hopefully for tonight is only 6 problems, guys. Have a good one. Enjoy your home play. See you guys tomorrow. Bye.